fellow mathematicians, we're going to take a look at another fairly straightforward homogeneous equation. Now, why is this differential equation homogeneous? Well, notice on the right-hand side, everything seems to be a degree 2 term. You have y squared and x squared, they're degree 2, x times y, x to the 1 times y to the 1, add those exponents, even though you can't, that seems to be also a degree 2 term. So here, everything seems to be the same or homogeneous of degree 2. All right, we can jump immediately to our substitution, y equals u times x, and the substitution from the product rule for the derivative. Let's just go ahead and plug those in. Left side, that's going to become x times du over dx plus u. And on the right side, all y's we're going to replace with u times x. And we'll take our time with the algebra. All right, we're going to get u squared times x squared. Go ahead and use parentheses if you want, but you're probably okay with that. Your x times y term, that we can write as x times ux. All right, and then in your denominator, you're going to keep that as x squared. And if we go ahead and simplify this, the left side will keep that the same. And if we go ahead and simplify, it looks like we can basically rewrite this part right here as u times x squared. And you can probably see the x squared in the denominator is going to divide and cancel the x squareds out in each of the terms in the numerator. So if you divide here, it looks like you'll be left with u squared. And divide here, you'll have u times x squared divided by x squared. That'll cancel to u. And again, this is really nice because the u's subtract out. That doesn't always happen, but it does for a fair amount of questions you'll see in a differential equations course. But again, not always. All right, so let's write down the simplified version here. We're left with x times du over dx equals just u squared. And remember, your substitution should convert the homogeneous equation, the original differential equation, into one that is now separable. And this one easily separates. I can divide the u squared to the other side and then multiply dx over and divide by x. We'll write this as 1 over u squared du equals 1 over x dx. All right, to make the integration as simple as possible, let's go ahead and rewrite that as u to the negative 2. And that should be very simple to integrate here. Let's go ahead and get through that work. U to the negative 2 du equals 1 over x dx, and we will integrate both sides. All right, very simple here. We don't need any integration methods. Looks like we're going to get negative u to the negative 1 and then equals natural log of x plus c. And that integral on the right-hand side pops up a lot for homogeneous equations, integrating 1 over x dx. All right, let's just go ahead and simplify this before we back substitute. We'll write the left side as negative 1 over u. We'll keep the right side the same. And now we can go ahead and plug in, back substitute for u in terms of x and y. And remember, that is equivalent y equals u times x, equivalent to u equals y over x. So if you just go ahead and plug that in here, we get negative 1 over y over x equals natural log of x plus c. And you might have done the work already. Go ahead and flip that, and we can write this left side as negative xy, and then equals natural log of x plus c. All right, and there we go. Now this is a perfectly fine solution, but a lot of times these might be simplified and cleaned up. And what could be done here, we can just easily get rid of fractions. Let's multiply everything by the variable y. So multiply this left side, you'll be left with negative x, and then equals y times natural log of x, and then plus c times y. And both of those are perfectly acceptable. This one just looks maybe a little nicer and a little cleaner. So let's go ahead and box both those since they're both fully acceptable and full credit, at least in my differential equations course. Hope you enjoyed this short, straight to the point problem solving video. If you're learning a lot, support the channel, like and subscribe.